Dear students and learners, today we are going to learn about an important topic which is widely useful in our day-to-day life. The name of the topic is coordination chemistry. Why the coordination chemistry is so much important in our day-to-day life? We are used to live in the apartments, buildings, home, like that. Only the construction part is not enough to stay in home. But the thing is, staying in home in a pleasant manner, we require the painting, beautiful color painting. For the painting, what we are using, different colors, vibrant colors we are using. And nowadays, there are different. There's a paints companies are available like Neurolac, Asian Paints. There are different paint companies are available. They are used to go for metallic painting also to make the wall which will be very shiny like that. Olden days, but the olden days concept, how the painting was started, the peoples, how the paints they are started after building the house, the peoples they are able to paint. Olden days only whitewash, the calcium carbonate is available. They used to just put the calcium carbonate in the home, that is a whitewash. Why they are using, why we require whitewash? Because when we whitewash, what happens? The light intensity, the light flow will be more in the white color. What happens? It looks very, that's a very clear image, very clear in their homes. The light will be fall on the particular thing. But the thing is now, olden days, only whitewash, only white color if you go for home, that is not enough. Olden days, we will call it Berlin, and they used to Berlin painting as well as the Berlin blue, we will call it the Persian blue color, where there's a complex case Fe4, Fe, CN6 thrice. The name Fe4, CN6. This particular complex, is also called as the Persian blue. Olden days, peoples and they used to paint only with the help of blue color. But after that, the Persian blue color dye, which is very costly olden days, that particular dye they are used to add in the white color. What happens? The white color becomes light blue color. What happens? It gives more intensity, it gives more lightning, let us say lighting. Okay, a more absorbent lighting, that is what we call as the likewise. That's why what we will do when we clean our innerwears, what we'll add, we'll add ujala, that different blue color. We'll call it the nail blue. Nail blue is nothing but it is all already called as Persian blue. The formula of Persian blue is that. Okay, now coming to the part we have in coordination chemistry, whose father of coordination is Alexander. Sorry, the father of coordination chemistry is Vernier. But the thing is, why I have given the name Alexander? Alexander used to go for war. He is a very intelligent person. Alexander the Great is a very intelligent person. What he used to go for when he goes for war, he kept some kind of roots in the packets. Okay, the roots he will apply to the skin, total skin. What happens? All the soldiers from the Alexander part, they will apply that particular roots. What Alexander is given, that particular roots, they will apply it in their body. Why? The root, particular root, will it shows some kind of blood color, flowing of blood like that. What happens? The different, that is the opponent force, the military, the soldiers, they will think that their peoples, the Alexander T, they are already some kind of they are injured, they will think that. That's why they become lazy. So what happens? Alexander, the root, what he applies in their body, the name of the root is called rubia, that's a rubia tinctum, that is a tinctum, rubia tinctum. Okay, the formula is also available. It's used. We know that thing he was applied the concept. But in coordination chemistry, father of coordination is 1 year. But today we are going to learn about a topic called isomer. Iso means same, mer means part. The definition of isomer in coordination chemistry: molecules are ions. Molecules are ions having same chemical composition but different and atomic structure. That is called isomer. This phenomenon is known as isomerism. This phenomenon is known as isomerism. The isomerism, which is mainly classified into two categories. One is called structural, another is called stereo. Structural isomerism, another is called structural as well as stereo. When you talk about structural isomerism, it was again classified into 6 categories. Was again classified into 6 categories. One is called ionization. Another is called hydration. Another one is called coordination. Another one is called ligand isomerism. Another one is called polymerization isomerism. Hydration, coordination, ligand isomerism. Another one is called ion. There is a metamerism. Okay, ionization, hydration, coordination, ligand isomerism. Another one is called metamerism. Another one is called polymerization isomerism. Polymerization isomerism. Sorry, this is I think position isomerism. Okay, ionization, hydration, coordination, ligand, position as well as polymerization isomerism. Okay, we'll start with what is the definition of structural isomerism. Let's start. What is the definition of structural isomerism? Molecules are ions. Molecules are ions. When you talk about molecules are ions, it deals about the structure of the molecule. This particular isomerism, it only deals about the structure of the molecule. Okay, that is the definition of the structural isomerism. But in ionization isomerism, there is only exchange of ions. Ions will be exchanged. Ions will be exchanged. When you talk about hydration isomerism, okay, only the water molecule will be exchanged from one complex to another complex. When you talk about coordination isomerism, here also the ligand between metal and ligand, the coordination will be shown. In ligand isomerism, in position isomerism and polymerization, I will show in the explanation part. When you talk about stereoisomerism, it was classified into two categories. What is the definition of stereoisomerism? This particular isomerism, the molecules or ions which are arranged in a spatial form, that is called stereoisomerism. Okay, again this particular stereoisomerism, stereo means here not sound. Stereo means molecules which are arranged in a space. Okay, we see that this particular isomerism is again classified into two categories. One is called geometrical. One is called geometrical, another one is called optical. When you talk about geometrical isomerism, it is also known as cis and trans isomerism. When you talk about optical isomerism, okay, here it is a very simple and we will call it that D form and L form will be available. D and L isomers are available. Okay, but the thing is, don't think that when you talk about geometrical isomerism, it is about the geometry of the molecule. When you talk about optical isomerism, when you pass a plane polarized light to the molecule gets rotated with the help of a light gives energy to the particular molecule. The molecule gets rotated when it will rotate in clockwise direction plus 180 degree clockwise. That is called exoform. When it will rotate in the anti-clockwise direction minus 180 degree, it is called levoform. There are two things that are available. Okay, it is very useful in our medicinal field. Okay, now we will talk about the ionization, hydration, coordination, ligand, position, as well as polymerization here. Let's start with ionization isomerism. In ionization isomerism, compound which have same composition but L is different due to the different ions. In ionization isomerism, very simple definition: compounds which have same composition, but L will be different due to their ions. Okay. It may be in solution or like that. Okay, we will see the example. Just try to get it. Cobalt as metal, pentamine, okay, this gives S422 minus ion and CO NH3 fine. This will be replaced here. Okay, Here SO4 will come here. This particular ligand will go outside Br and it gives Br minus ion. Okay, just there is a only exchange of ions. Okay, that is called ionization isomerism. When you talk about hydration isomerism, this is the over. When you talk about hydration isomerism, hydration isomerism, linkage isomerism, it arises when a monodentate ligand, monodentate ligand, when a monodentate ligand has two different atoms, which are available, which are available for coordination. Linkage isomerism, when it arises when a monodentate ligand has two different atoms which are available for coordination. That is called linkage isomerism. Let's we'll see the example. C2 NH3 5 NO2 is a complex, and this particular complex, we can write it as CO NH3 5 O and O and Cl2. This particular example shows that how the linkage isomerism link between one metal to another ligand, That is, it shows the linkage of coordination between nitrogen as well as oxygen. Okay, this particular thing is an example. Maybe if we want another example, we can able to write it. But the thing is, one example is enough for particular this thing here. Let's we will see the position isomerism. In position isomerism, the definition of position isomerism is nothing but there is a change of position of ligand from one complex to another complex. That is called position isomerism. We'll see this particular thing. It is actually found in many bridge complexes where we can able to find the position isomerism. We'll see the placement of ligand in position isomerism with the help of this example. Okay, now I will take as this particular thing is a tetraamine as a ligand that is coordinated with this cobalt. This is a complex. It's having charge of 2 plus and can be written in the form of this chlorine particular thing, I will divide as this particular chlorine as a ligand. I will take here chlorine NH3, this particular thing, same as it is. So I will write as this. Totally how many NH3s are there? There are 6 NH3s are there. 6 amine ligands are there. For that, I will write it as this particular OH, this particular OH, and this particular CO, the cobalt. And here I have kept 3 amine. So another 3 amines I can also kept here as a ligand. Okay, I can also kept another one Cl only. Okay, this is called position isomerism. There is a change of position of ligand from one complex to another complex. Okay, we can write it in the form of like this. Okay, now another one. There is another one. We have example. We will take another. We will go with polymerization isomerism. Okay. Can you able to understand this particular thing? There is a change of position from particular this complex to this complex. Here there are 6 amine groups are there. There are 4, another 2, totally 6. It is a bridge complex. It is a bridge complex. Because why it is called as bridge complex? Because it contains two metal atoms, central metal atoms. Okay, it is a bridge with OH, and it is having amine as a ligand. This particular thing we will write the following this format. Okay, there is one question isomerism. Next one we will see the polymerization isomerism. Isomerization means the isomerism. It exhibits the compound. Which have stoichiometric, stoichiometric composition, but the molecule composition have some examples. Let's see that the position. There is a polymerization isomerism. What is polymerization isomerism? Polymerization isomerism. In polymerization isomerism, you know very well that what is polymerization isomerism. Let's see what is polymerization isomerism. It is mainly used for the stoichiometric compounds which have molecular composition. We will see the example. Okay. The platinum I have taken as a metal. Amine here, and this one we can able to divide into 2 complex formations. How? This PT NH3 4, okay, NH3 4. Because it is a stoichiometric composition, no, we will go with PT Cl. Sorry, PT Cl4. This complex formation. This is called polymerization isomerism. Okay, boys, students, I thought today we have seen isomerism, structural isomerism, isomerism, we have the ionization isomerism, hydration, coordination, ligand, position, as well as qualitative. So far, this is the important question. Now we'll go with stereoisomerism. I have given the